Hello everyone, welcome to another AP Computer Science video. In this video we're going to continue working with arrays to get more practice, as well as using them in methods. The last thing that we did in our previous video was using arrays, but we were using them as inputs to method. This is kind of an important thing because often methods make code easier to read and more reusable. And now that we've introduced arrays as a way to have more content, it's a good idea to blend them. And we want to be comfortable with the ability to accept one or more arrays as input and return arrays as well as output values. It's possible to generate an array inside of a method and then send back that answer to whoever called the method. This is a common technique and helpful in building complex programs. Last time we did a simple method to print arrays. This is good to practice and good to see the content that's in an array in a quick manner. So we're probably going to reuse this method just to make ourselves, save ourselves a little bit of work when it comes to displaying answers. We also did get first that accepted an array of strings. We see how arrays of objects essentially are the same as having individual objects and variables, and we can access all the object methods by accessing the object from the array. And finally we did one with booleans, which is just another set of primitive values. It shows just more practice. So we're going to continue on. I'm going to make a new class just so we can have a little bit more space. I don't want to cram this file with too much content. So I'll make a new class in the array stuff package, and I'll call it more array methods. And again, we'll put a main, and we'll start building some methods to use in our main we can test with. Let me go use my shortcut. And there it is. I also want to, because I'm lazy, I'm going to copy that a print method because it is useful, and we'll maybe edit it for different things. If we're using integers, then it's useful, and we can edit it for different data types as we see fit. So I'm going to go to array methods, and I'm going to go ahead and copy this static method print array. It is a very useful method to have. So I'll put that one underneath it, and we can always refer to it. And if we need to change the data type for a particular, if we're using doubles or booleans or something like that, we can also change it or make duplicates. So here we are. So the first thing I want to do is make a method, because these are common algorithms. The idea is that there's a lot of things that if we have collections of data, what kind of operations do we want to do on collections of data? Right? Having one number might be useful, but if you have many numbers, what kind of things might we do? Right? Some common things are finding the minimum value in a list of values. So if I have a bunch of integers or doubles, what's the smallest double available? If I have a collection of values, I want to find the largest one available. Those are basically the same problem, but in reverse. Those are useful. So we want to be able to do those things, and putting them in methods can be convenient. And another method that might be useful, another functionality that is pretty common, is just finding something. Given a list of data, is the content that I'm looking for contained within that collection of data? And if it is, then I want to return a true, or maybe even return the index where I found it. So I'm finding a match. We've kind of used string methods that have this idea, right? When we used index of, it's basically a search. And if we found something in a string, then it would return an index where it began. And so having a kind of a mimicked version for arrays could be very helpful. And again, the data type is the only thing that maybe dictates how we make our comparison. So for strings, it's pretty easy. For objects, we may have content we have to check, but for primitives, it becomes trivially easy by using our comparison operators. But let's start off with that minimum. Let's make a method that, given an array of doubles, finds the minimum value, right? So the idea is that, well, if I have a bunch of different numbers, can we find the smallest one possible? Or ints, and really the type is not that important, it's just finding the smallest one, because at the end of the day, it's just about the comparison. So maybe we'll stick with ints just to make it easier. So let's go ahead and do this. Let's set up a signature for the method. Again, the method's going to be pretty common, I think, in this format. We're going to make it public because we want someone to use it. Static, because again, we're in the context of just kind of using it loosely with no object context. And then not void, but because we're going to find the smallest value in a list of integers, we're going to assume integers, then our return type should be int, because we're going to return the value. So if we have the numbers in a collection 1, 5, 2, 45, 13, then we want to return the 1, which is an int, right? The data is what we want to send back. And so we're going to say int, and we'll call it find min. So now here our input is, again, in order to look through an array, we must be given a reference to an array. And again, a reference means that when we copy the content as a parameter, we can't copy the actual array, but we instead copy the address in RAM, and if we can follow that address, we will find the object in RAM, and we can access its content and use bracket notation to see the values and do what we need to do. So again, we're assuming integers, so we need an array of ints as our input. So int, again, the brackets are what change it from a single value to multiple values in an array. And then the name of the variable is not important, so I'm going to call mine ARR. I like to just say ARR for array, right? And so now, what is the work involved? There are several steps we have to consider. And we don't want to make too many assumptions. And one assumption that I know is a kind of common starting point, and it's not unreasonable, is to say, okay, well, let's pretend our minimum is 0, and then if we find anybody smaller, or we assume that the minimum is some value, maybe a really big number, 1 billion, 2 billion, the maximum integer. And then we say if there's anyone smaller, that's the new minimum. And that's not unreasonable, but we don't necessarily want to have to deal with max val. We could do that, but instead we should maybe say, you know what? If we have a collection, let's just pick the first one, and that's the smallest one so far. And we'll look through the rest of them, and if anyone beats it as being smaller, then that'll be the new small one. So we do need to keep track of what the smallest value we've seen up to some point is going to be. So we're going to make a variable. Let's go ahead and do that and create a variable. We'll call it min. And what we're going to do, again, a good strategy is to assume the first value is the smallest. Now, again, we are making one bold assumption, that the length of the array is at least 1. It's possible to make an array of size 0, as worthless as that might seem. And so here, if we do use the bracket notation to access spot 0, that's the assumption that there's at least one value. We're not handling the fact that it's size 0. We could maybe do that, but then what would the minimum be in an array of size 0, right? The return would be meaningless. If I put -1, that would imply it was a negative number, but negative numbers are integers, so was that really the minimum? No. So we'll just let it crash if they try to sneak in an array of size 0. Otherwise, they must have some positive size array, so we will say the first item is the minimum, right? So we'll say, assume the first item is the smallest. Now let's just go about our business and search and look at every spot. The limitation here, the reason this might not be the most efficient algorithm, but it is one that we can't avoid, is in order to guarantee we found the smallest one, we must look at every single spot. So there's no intelligent, smart moves we could make to jump around and be faster. Often when we come up with algorithms to solve problems, we do want a smart implementation, and the less work we do, the better. But in this situation, the work of comparing values, we can't really avoid checking all of them. Because if we skip one, that one might be the smallest one. If we skip it, we're out of luck. We've gotten the wrong answer. So we can't skip anything. So if there are n items in this array, where n can be 1,000,000 or 10 or 50 or 7,000, we need to look at all n items. And that's not a terrible thing. Really, there's nothing better we can do. So let's loop through and look at every single spot. And again, you can use any loop you prefer to do this. But again, I think that when it comes to arrays, since we know the beginning index, and we know the last safe index because of the length, a for loop kind of lends itself to making this very easy to do. So I'm going to use a for loop. I'll use the classic I starting at 0. I is less than the length of the array they gave us. Length is a property, so we do not use parentheses. And we go to each spot one at a time from 0 upward. So next, what are we doing in the body of this loop? What work are we doing? We should be determining, is the one I'm looking at right now in this collection smaller than my smallest so far? If it is, it must be the new smallest, right? It's better, it's smaller, it's the minimum now. And maybe we'll find an even smaller one later on, but we're talking just right now between the current smallest and the one I'm looking at in the array. So we have to make a comparison, so we should maybe write an if statement to ask that question. So let's try that out. Let's say, well, if the current value, so our array is called ARR, if the ith value, so I meaning the index, so it could be 0, 1, 2, whatever one that happens to be, is strictly smaller than the current minimum value, that means it must be the new minimum, right? It's smaller, so it's got to be the winner, so it has to be the new smallest. So we can ask this question: is the current value smaller than the current minimum. And if that's true, then our minimum should be adjusted to the current value. So we could say min is equal to ARR on I. That's the new smallest. Great. And then, of course, this loop would repeat. So the next time, potentially the next one would be smaller, and so on. And it would keep going, keep going. And the idea is that if this loop ends, which it should, whatever value was smallest will now be stored in min, and we can simply return that value. And there it is. So again, I could have shortened this method a lot. I have a lot of extra space. The curly braces are not necessary because they're only one line. But there it is. Right? It's a pretty easy implementation. We say, look, assume the first one's small. Now, there's one improvement we can make. If we take a moment to think about it, we can probably figure out, well, there's one thing that I'm not doing. And again, it's a trivial change, but it's one that could improve it by a margin, what the performance of our implementation. And so that improvement is, if we start at 0, didn't we assume the first one was the smallest? So why would we check against the first one again? It's going to be equal to, right? Because it's the same value. So since we assume the first one was the smallest, let's just begin. Oops, I forgot to silence my phone. If we begin at spot 1, then we get the best of both worlds. We're looking at every value. We didn't have to look at the first one because it was already assumed to be the smallest, and then we can go about our business of checking who is the minimum, who is the minimum, who is the minimum. At the end of our method, we have the smallest one. And that's a pretty good implementation. It's very simple. And what I would ask you to do now, pause the video and implement a find max. Given an array of integers, find the maximum, the largest value in an array, right? So we have a bunch of numbers and find the biggest one. So I would say pause the video, give yourself a moment, implement another method called find max that accepts an array of integers. We'll assume the same values. We don't know what's in the array, but they are integers. And then return the maximum value found. So give yourself a moment and go ahead and try that. So hopefully you've implemented your find max, and I'm going to go ahead and do that right now. And I'm going to be lazy because they are very similar. And if you can do the find minimum, the find max is almost the same thing. In fact, the only difference I'm going to make is I'll change my variable names, and there's only one key difference. So I'm going to go ahead and copy the entire method. I'm going to implement, I'm going to paste it. I got to change the name. So find max. I'm going to be lazy and replace wherever I see min with max, just because I like the consistency in naming. And the only change is from a less than, we make it a greater than, right? So the question we're asking, is the current value larger than the current maximum? Right, find the largest. We assume the first one is the largest. So again, the same idea. We assume the first one's the largest. We look at every other one and say, are you bigger than the largest we've seen so far? And if you are, then you must be the new largest. And therefore, we should be able to return you as the largest, right? So I think those methods are complete, and now we can test them. Now, again, we should validate. Maybe we made a mistake. Maybe I misinterpreted something, but we should check it. We should never just assume that we're right. There are many times that we miss some small scenarios. So let's check that. And again, I did mention the size 0, so that one's fair game to intentionally miss. I expect an error to happen if we try that. To test it, thankfully, we have our print array to see the content, and we have our excuse me. We have our methods to test this. Let's implement or create a literal array. That way we can test really easily. So let's try this. Let's go ahead and say, we'll say int array, and I'll call it numbers is equal to, and instead of initializing it with the constructor and filling it in with blanks and then filling in the values, I'm just going to hard code an array as a literal. So I'll put something like 7, 3, 8, 14, 12, 11, 10, 4. And there it is. Right? So remember, we can make a literal array by putting values of the same data type, comma separated in a set of curly braces. That's a literal array of integers. And so now let's go ahead and test this out. Let's go ahead and find the minimum. So I'm going to print out, because it does return an int, and I'm going to print that directly. I'm going to say find min. Now, what is the input to find min? It is an array of integers. The reference is copied, so I want to pass in numbers. And basically, ARR points to the same content as numbers. And then when the method is running, ARR is numbers, and it should find the minimum. So let's go ahead and put numbers. And similarly, okay, what am I doing wrong? We have maybe some mistake. find min. I put fin min, find min, and it should be find max. There we go. And then let's go ahead and copy it and do the same thing for the maximum, and we should get, our answer should be 3 and 14. So let's see what happens. Our output is compiling, and we should see an output in a moment. Come on. Okay, so there it goes. It took a little bit of time. And there it is. The minimum was 3. It searched through them all. 7 was the original minimum. It said, is 3 smaller than 7? Yes, then now that's the new minimum. And is 8 smaller than 3? No. Is 14 smaller than 3? No. And 12 smaller than 3? No. And so on. And eventually, it went through all of them. 3 was the best it could do, and that was the minimum. And then similarly for the max, it said, okay, well, 7 is the max. Is 3 larger? No, then 7 is still the max. Is 8 larger? Then now 8 is the max. Is 14 larger than 8? Then yes, 14 is the largest. Is 12 larger than 14? No, no, no. And the end result is 14 is our maximum, right? Again, if these were not integers, doubles, there would be no real difference except the data type. If these were booleans, you really couldn't do a minimum or maximum because there's only 2 possibilities. For strings, in order for this to work, to find the quote-unquote minimum string, we would have to establish what does it mean to be the minimum string. Does minimum string mean the least number of capital A's? Does it mean the length? Does it mean the number of times there are spaces? And so the concept of the finding minimum is a typical algorithm. However, when we say minimum, we must mean something specifically. And so if we're going to implement it, we have to know what is meant by minimum. With numbers, it may be obvious. With class types, so for example, what is the minimum security bot? Is it whatever security bot has the lowest security level? And does whether it's active or not play a role? That's a decision we'd have to make. If we're dealing with bank accounts, what does it mean to be the minimum bank account? Is it by ID? Is it by the owner's name? Is it by the balance? And again, those seem like silly questions, but the reality is we must know those things to implement them properly. And finding the maximum is the same problem. If we can determine what it means to be the maximum, then the algorithm is easy and consistent. Right? The only thing that changes is this comparison might be a little more complicated than it looks right now, but still quite manageable. So I think these are great methods. Let's do another method. Let's try finding anything. You give us something to search for, and we tell you whether it's there or not. And more specifically, we return the index where we found it, if we found it. And if we didn't find it, we'll do kind of what index of does, and we'll return -1. So we're going to search through an array, and if it's there, then we return the index. Otherwise, we return -1. And let's go ahead and do it with strings just so we can see that the comparison mechanism is arbitrary. We just have to use the appropriate comparisons to do this. So to save some space, I'm going to shrink this. You can hit these little minuses to hide the code of particular methods. And there we are. And so let's go ahead and try this out. So we'll make a method, public, static. And now it's also going to be an int return type, but here the int is not a value, it's the index in which we find a value. So we'll say find. And so our input will be 2 things. The collection we're looking through, what are we searching in, right? And then the value we want to find a match for. I'm going to use strings, so we'll make an array of strings, and we'll call it, strs, and then the string we're looking for. So we'll say search. Again, the name is not important. And so what we have to do is we have to say, well, can we find it? So there are many ways to do this. We can pretty easily just return a value. We can make a variable. In this case, I think it's convenient to just search through the array. If you find a match, return that index immediately, and then the loop is over and the method is over. And if somehow we fail to find a match, then at the end of our loop, we need a return that's guaranteed, and therefore we would have a return of -1 at the very end. So we don't have to make a variable. We don't really need to do any of that. It's just a matter of style. So let's try this out. We'll say, let's look through every spot. Again, thankfully, this is such a common technique that there's not much thought once we understand it. We start at the beginning. We continue as long as we're within the range of the array. So string.length. We go up by 1 part each time. And then now our question, here's the work. Is there a match between the current string that we're looking at in our array and the one that we are searching for. So our question, I think it's pretty easy. Since we're going to be doing exact matches, actually to guarantee we have an exact match, let's say we're going to ignore case. So whether the words are capital or not, or the search is capitalized or not, we should go out of our way to check for content not capitalization. So I'm going to do a little bit of extra work. We can do it all in one line, but I'll put it in separate lines. So we'll say string cur lower is equal to, and I'll get the current value and put it to lowercase. So we'll say the array that we're at, that ith value, that's a string, so I can call string methods, and therefore we should say to lowercase. So that string is an object. That object has methods. Could I have put this in a string and then called the to lower on that string? Sure, but we can do it in one line. This is basically represents the string that was returned. To lowercase makes it lower. Let's do the same thing for other one. We'll say, and here's where we're being a little inefficient if we do this every time. Perhaps I should make it lowercase from the beginning, so I'll maybe do that. I'll move it up here before our loop, and we'll say search lower is equal to search dot to lowercase. And now I don't need to do that here, so now I can ask my question, and now I'm not worried about messing up because of capitalization. So we can say if the current lower is equal to the search lower. If that's true, then we know our answer. We found a match. Therefore, we should return the index that we're at. Now, what variable represents the current index that we found our match on? Think about it. I is what was controlling our loop. It is also the index into the array, so I must be the value. So we can simply return I, whatever number that happens to be. And then finally, the last step, if we manage to go through this whole loop and this if statement is never true, we would never escape the method by calling return, so we must return now, and it's basically because there was a failure to find a match, and so we can simply return -1. Right now, the returning -1 is not necessary. You can return whatever you like. Again, the reason it's a good choice, and the reason it was a good choice for strings, is because it's not an index. So it's like the first number we can think of that's a non-valid index, right? Because 0 is an index, and we can't put a positive number just because the index would depend on the string. Here we know there is no array that has an index -1 that can be used, so it's convenient to have a return. It's not necessary. We could maybe crash the program. We could return, 0 if we thought that was appropriate. Whatever we think is reasonable. But a -1 is a good choice for a return type when we fail to find content. And so this is a pretty good choice, I think. And I want to do one more method that's a little bit different. Instead of searching through an array, we're going to build an array. That'll be the final step. And this is a convenient thing because often we have to construct arrays in methods and then return them as a value. So we haven't returned anything but regular class types or primitive types as return statements, values, but we can also return arrays, and that's a pretty big deal. So let's do one last method. This method, what I want it to do is to accept a number, 1 or larger, or 0 or larger really, and return all the powers of 2 up to that number. So for example, if they give us the number 4, I want to return an array that contains 2 to the 0, 2 to the 1, 2 to the 3, 2 to the 4. So that's 5 numbers. So if they give you a number, then it's always going to be the number of items in the array that we're going to generate is going to be 1 more than that number. So they give me 7, I want the numbers from 2. I want to do the numbers from 2 to 2 to the 0 all the way up to 2 to whatever the number is plus 1, or equal to that number. So let's try that out. So public is our access modifier. We want someone to use it. Static, because we have no context. Now here's the new thing. We are allowed to return arrays as values. So the only change is that the brackets are now present in our return type. So now I'm not returning a single int. I'm returning an array of integers. So that's a return type. And this is why I had made that suggestion early on that when you declare types, it's a good idea to put the brackets in front of after the type because that way we don't get any confusion. Here we kind of have no choice. So let's call it power or pow2s, right? And then the input will be a simple number. So they give us n. I want to generate an array that has n powers of 2 from 0 to n. So n is 3, I want 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. So actually 4 spots. So the number of answers we're going to generate is 1 more than the n they gave us. So our answer has to be, I want to return all the values, not just one of them, so this is why an array is a convenient choice. Right? The question might have been asked early on, how do I return more than one thing? The answer is usually you couldn't. But now we can return arrays of content. But there's still a limitation. The arrays must be one type, so I can't return like a string and an integer, not yet. But I can return an array of content. So let's try that. To make our array, we're going to construct a temporary variable. We'll call it POWs. And we will initialize it to a new array of integer values. And now, again, we said, how big should it be? How many answers are there? If n is 5, there are 6 spots, 2 to the 0 to 2 to the 5. If n is 1, there are 2 answers, 2 to the 0 to 2 to the 1. So that would say, if there are n numbers, then it's from 0 to n plus 1, so we need n, or 0 to n, which is n plus 1 spots. And there it is. So now we have enough spaces. And now, what can we do to fill in each spot with the correct power of 2? The first index is always going to be 2 to the 0, then 2 to the 1, and then 2 to the 2, and then 2 to the 3, all the way up to and including 2 to the n. So before I implement it, try doing it yourself. Pause the video, think about how we can create the powers of 2, and then assign them to the correct array spot, and then at the end return this entire array as an answer. So pause the video, give yourself a moment, and then I will continue when you're ready to see an answer. Okay, so I hope that you're back and you've solved this problem. I think it's an interesting one, and the ability to assign an array and construct and give values is a useful tool. So here we go. I'm going to say we can try a typical loop, 0 to n, because 0 is the first power I want, n is the last power. I want to be inclusive. So the only difference here is I'm going to say I less than or equal to n, because I want I to become n at some point. I'm going to go up by 1. And I'm going to say the array at the current spot, the ith spot, so the 0th spot, the first spot, the second spot, is equal to math.pow 2 to the I. Where if I is 0, it's 2 to the 0. And if I is 1, it's 2 to the 1. And if I is n, it's 2 to the n. And now this, of course, returns a double, so I need to cast my value because I chose to do integers. And again, I don't think it's a problem because we are doing powers of 2. It's just to force it to be an integer. We cannot have an implicit cast. And then, of course, the last step is to return the entire array. So this is the difference, is that when we return an array, it's not just one value, it's the actual array reference. So it's the memory address. And this is an important point to take, is that if POWs disappears, that's okay because whoever was given back this address still has kind of the pathway. It's like if I have my address book and I write the address to the house that is POWs, and when this method ends, my address book disappears. If the address book disappears, then POWs is gone. I can't get to the house. But the return makes a copy. So my friend comes and photocopies my address book. Now he knows where POWs is. And so when I disappear with POWs, he has a copy of the POWs address. He can make it to the house. And that friend is essentially the caller in our main. So that's the idea that we're going to have here. And so now this is nice because we're going to be able to use our print array to prove that this actually works. So let's try this out and see if this works. I hope the implementation makes sense. Again, I chose 0 to n and inclusive because that's what I had asked for, is I want to include n. I want to start at 0. And so even though typically we say strictly less than, in this situation it works out, right? When we are n, there is one extra space, n plus 1, because the index is always off by 1, so it matches up. So let's test it. So here I don't actually need, the input is not an array, it's simply a number. So I'm going to, now, and the return is an array, so in order to get the answer back, I need to keep that answer somewhere. So I'm going to say, let's refer to, or contain, or have the ability to keep a copy of a reference to an array. So I'm going to call this one POWs again. Again, the name matching is a coincidence, it's arbitrary, because they're different scopes. But now I'm not going to create it from scratch here, I'm just going to call the method, and it should generate an array and return it. So I'm going to say POWs, or POW2s? Yeah, POW2s. That's what it's called, POW2s. And the number is, so I'm going to go ahead and put 5. So I expect to see 2 to the 0 up to 2 to the 5, which should be 32. And notice there's no error. The return type is int array. The variable is a reference to int array and matches. There's no conflicts. And now nicely, because we have our print array method that we, our print array returns string, so let's go ahead and fix this. Let's make this int. And notice there's no change, only because we didn't refer to any string specific methods. And so if I do this, I should see the numbers from 2 to the 0 to 2 to the 5. So let's go and take a look. And so now I can say print array and call powers. The input is this array. And so now you can see the power of methods. The work is happening. A lot of code is running. But from the perspective of main, it's all compacted into method names. So let's see. And there it is. Right, there's the minimum and the maximum. 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. 2 to the 4 is 16. And 2 to the 5 is 32. And this is very flexible. And let's try it. I mean, let's see if it works. 0. So from 0 to 0 should be just 1. Let's see if it works. And there it is. It does seem to be flexible. Now, negative numbers will not work because there is no 2 to the negative, at least not in terms of power. I mean, it actually might work. Because you can have negative powers and it's just like a fraction, but they're ints, so we'll get a crash, right? We can't use negative. We're referring to an array, so it does not work out. But let's go ahead and put like, I don't know, 10. So 2 to the 10 is 1024, so we should see that as our last value. And there it is. See, it's expandable, flexible, and it works across the board. All right, so I hope you see some of the power we have. It does take a little bit of planning, but really, once we're comfortable with making methods and using arrays as not just a single piece of data, but multiple pieces of data, and our reliance on our reliance on loops becomes bigger, but it gives us a lot of power and control over our data, and we can do quite a bit with it very, very quickly. In a future video, we'll do even more with arrays. We'll see that there's a lot we can really expand on. In particular, I want to focus on using objects that are not primitive. We've done strings, but strings are too easy. We're going to have to make our own object, or refer to one that we've created, like a bank account, and make an array of those things. And that's a bigger process and a more powerful idea. So I'll see you in that next video.